In the first lab this year, its elemental lab, our task was to determine the identity of a mystery metal. And the purpose of this lab was mainly review. The concepts weren't too difficult to grasp. The objective was to just get us back into the lab and familiarize ourselves with the lab setup, lab safety, and our equipment, and also to start remembering basic chemistry and make sure that there are no real errors in the way we went about our problem solving, our procedure, our setup, and calculations, just so we could correct things early on and be more efficient as the year went on. And when we received our mystery metal, it looked kind of like a crumpled up foil. It was fairly malleable and it came in these just tiny crumpled up nuggets, and we thought that since it was malleable and crumpled, it had originally been some sort of thin sheet or a foil. So we hypothesized that it was either aluminum or tin. But, of course, a hypothesis is just the beginning of the scientific method. So we had to test our hypothesis by finding out the identity of our mystery metal. And to do so, we had to find certain qualities that are unique to one substance. And there are several of these qualities. The ones we chose were density and the specific heat capacity. And we just performed multiple trials of these calculations in our lab. So to find our density, we used the formula density equals mass over volume. And we found density in grams per milliliter. So the first thing we did was we weighed the mass of all our little pellets of the mystery metal combined on a balance. And then we filled a beaker with about 18 milliliters of water and dropped all our little pellets of mystery metal into it and recorded the change in the volume of water. And that change is equal to the volume of the mystery metal. And to get density, all we had to do then was divide our mass by our volume. After we found density, we found the specific heat capacity using the specific heat capacity of water and a calorimeter, and the equation mc delta T1 equals mc delta T2, which means that the heat lost by the metal equals the heat gained from the water. So to go about this, we filled up a calorimeter with about 80 grams of water and heated our mystery metal up to 100 degrees Celsius in boiling water, and immediately dropped it into a calorimeter and recorded the temperature change using a thermometer. And here is our density data table. Our average mass is 0.801 grams. Our average volume is 0.18 milliliters. So our average density is 4.4 grams per milliliter. And in our specific heat data table, our average mass of our metal is 0.187 grams. The average temperature change was 0.25 degrees Celsius. The mass of water is 80 grams, and the specific heat of water is 4.186 joules per grams degrees Celsius. And the average specific heat of the metal that we calculated is 9.25 joules per grams degrees Celsius. So in conclusion, the identity of our mystery metal seems to be titanium, because we calculated a density of 4.4 grams per milliliter, and titanium has a density of about 4.5 grams per milliliter. And unfortunately, we couldn't use our specific heat capacity to identify our metal because it was 9.25 joules per grams degrees Celsius, which no common metal has and is actually much, much higher than the specific heat of most metals. And there have clearly been some errors in our procedure. Obviously, the lack of 3 trials in our specific heat capacity calculation is a huge, huge error. It was made due to a lack of time. And obtaining more results would have been good. Additionally, we probably didn't drop the metal into our calorimeter fast enough, record the temperature correctly. Maybe we messed up calculations somewhere along the line with our algebra, and our procedure could have just gone overall much, much smoother. And additionally, our mass isn't perfectly accurate because to measure mass, we put a weigh boat on the balance and then zeroed it and then put our metal in. And if things shifted about, the mass could have gotten measured incorrectly because the balance is very, very precise. And if the weigh boat shifted over a bit, it would sense it differently and come up with a different mass. So in the future, we would probably redo our specific heat capacity trials and calculations and hopefully obtain a more accurate value that could more easily confirm the identity of our metal, and possibly find the melting point of our mystery metal, which we couldn't do because the thermometers provided to us couldn't handle high temperatures, and since the lab equipment wasn't ours to break, we decided to measure specific heat. But if we had lab equipment that would be safe for high temperatures, finding the melting point of the metal would probably reduce error quite a lot because taking a simple temperature measurement is a lot easier. And these processes, we could also use them to determine the identity of other mystery objects. We only got to work with one mystery metal in this lab, but there is definitely a possibility of more mystery metals in our future.